Hey guys, today we are going to learn about the distance formula and the midpoint formula. Now, the distance formula is basically the distance between 2 points on the coordinate plane. Now, it's super easy if the line is horizontal or vertical because you can just count the blocks. But as you see in this case, the line is diagonal. And we can't sit here and count the blocks because they're not even with one another. So you can't sit here and say, oh, there's 1, there's 2, there's 3, there's 4. No, it doesn't work that way. Now, last year you all learned about the Pythagorean theorem, which you may or may not remember. But the distance formula actually comes from the Pythagorean theorem. And the distance formula is this. D for distance equals the square root of x sub 2 minus x sub 1 all squared plus y sub 2 minus y sub 1 all squared. Now, notice the x2 and the x1. It's very similar to slope. Remember when we found the slope of a line, we used 2 points, okay, and we found the difference of the y's rise over the difference of the x's, the run. Very similar here in that we have x2 and x1. Now I have an example here. It's not on your paper, so you can have another one to look at. It says, find the distance between the points A, 3, negative 2, and B, negative 5, 7. So what I'm first going to do is label my pieces, okay? 3 is x1, and negative 2 is y1. That's just because that's our first coordinate, the first x that I see and the first y that I see. For this point right here, that's going to be x2 and y2. And that's just simply because that's our second coordinate. Now you could graph these on the coordinate plane to look at it, but all we need to do is substitute the values into the distance formula. Now the distance formula, I'm going to write it here again so you can see it. And then I'm going to substitute my values. Now, you are definitely going to want your calculator, okay? For sure. So the first thing I'm going to do is I'm going to match my x's, my 3, and my negative 5, okay? So I'm going to have D equals, I know this is not the best quality video, so y'all just go with me here. X2 is negative 5, so I'm going to write negative 5, subtract, and then 3 is x1, so I'm going to write 3 squared. You see how all I did was just replace negative 5 for x2 and 3 for x1, okay? And now I'm going to fill in my y values. Okay. And I didn't have another highlighter here, so I'm just going to underline. Here's my y2. There's my y1. So I'm going to have y2 is 7 minus y1 is negative 2. Now, notice we have minus a negative. So you need to understand that that's actually going to become a positive. If you don't, you do have your calculator. Now, you could type this all into your calculator in one fell swoop, but I'm going to be honest with you. I mess it up every time. I mess up my pluses. I mess up my minuses. I forget a parenthesis. I forget a squared. So I'm going to actually do it piece by piece. So it's going to be D equals the square root. I'm going to do negative 5, take away 3, which is negative 8. Okay. And then I'm going to do 7 minus negative 2, which is 9. Okay. Now I'm going to simplify this. D is the square root of, that's going to be 64 plus 81. And again, you might just type this all into your calculator all in one fell swoop. So D is going to equal the square root of 145 So your distance is going to be approximately 12.1 if I'm not mistaken. I don't have a calculator right in front of me. Okay? So that is how you find distance. Now, distance can be a decimal. Distance can be a fraction. What distance cannot be is negative. You cannot have a negative distance on the coordinate plane. Okay? So if you got negative 12.1, you did something wrong. Even if I put my car in reverse, I'm still going a distance. I'm not going negative. The same is true on the coordinate plane. Okay? So your distance will always be a positive value. All right?